here we are at Meteorology, which is your last unit. So with this one, meteorology is the study of weather. So what actually causes weather? Well, weather is caused by an unequal heating of the Earth's surface. Well, what causes the Earth not to heat equally? Well, the reason the Earth doesn't heat equally is because, going back to astronomy, with the tilt of the Earth in June, the southern hemisphere is tilted away from the sun, northern hemisphere is tilted towards the sun. So the more sun you have, or the longer the duration, the warmer the temperatures. You absorb more heat energy, and therefore you radiate more heat energy. So first one's going to be the tilt of the Earth. Second one we already talked about with heat transfer is land has a lower specific heat, so it doesn't take as much energy to heat it up or to cool it down. Water has a higher specific heat, so it heats quicker. It heats slower and it cools slower. So if I take you during the summertime to Lake Ontario, the land and the air is going to be warmer, all right, than the water temperature. I throw you in the summertime, the water feels cold because the water is taking longer to heat up. If we go back, say, the end of October, the water is going to take longer to lose its heat, so therefore it's going to be warmer than the land. So there's the unequal of that. Three factors that are going to determine what weather is. One is humidity. Humidity is how much moisture is in the air at that given temperature. Key is at that given temperature, because as temperatures increase, that means the air can actually hold more water vapor the higher the temperature is. So the key is how much water vapor you have in the air at that given temperature. The other one is temperature and pressure. So humidity, temperature, and pressure are going to determine weather. How do you forecast weather? You watch the news every 10 minutes, somebody's up there, one of the meteorologists is up there forecasting weather. Well, they're looking at using radar, they look at satellite images, because you got to remember, you have satellites that are flying all over above the Earth, reporting data back. The other thing is you look at computer models. If you watch the news, when they're forecasting, be it snow or be it rain, they'll talk about the computer models, and which computer model they feel is more accurate, or sometimes they say, the computer model says the rain is going to get up to like Route 20 and anything south, and Syracuse is not going to get it. And then from there, they'll adjust what they believe to be true or not. All right, what is an air mass? An air mass is a parcel of air that remains stationary. Parcel means a slice or a piece of air that's staying stationary. It's going to take, that air is going to take on the characteristics of where it's forming. If it's forming over water, it's going to be humid. If it's forming over land, it will be dry. Higher latitudes, you're going towards the poles, cooler temperatures. Lower latitudes towards the equator, warmer. So, if we look at your reference table, it has air masses on it. With that one, notice the 5 air masses. First letter is lowercase, second letter is uppercase. First one, CA, means continental Arctic. It's forming over northern Canada. And continental is dry, Arctic is cold, very cold. These are the days that every once in a while in the wintertime we have a snow day, but it's not snowing, but the temperatures are so cold. That's when the air mass is dropped from the Arctic, all right? Next one, continental polar, lowercase c, capital P. It's forming over southern Canada. All right, it's continental, so it's dry. Polar, it's going to be cool. This is when we have a cold front. It's dropping down from Canada. We're importing the air to Canada. All right, it's usually drier and cools us down because they normally have cooler temperatures, the higher latitudes. Third one, continental tropical. Lowercase c, capital T. This one's forming over the southwest United States, Arizona, New Mexico area. Continental meaning dry, tropical is warm, so dry and warm. The fourth one, maritime tropical. Maritime means water, marine. All right, so this one's forming over lower latitudes of the Pacific or Atlantic Ocean. For us, usually it's Gulf of Mexico. Maritime is going to be humid because it's forming over water. Tropical is going to be warm, so humid and warm. The fifth one, maritime polar. All right, this one's forming over higher latitudes of the Pacific or Atlantic Ocean. Maritime meaning over water, so it's going to be humid. Polar is going to be cool, so it's going to be humid and cool. We need to talk about what prevailing winds are. All right, prevailing winds and upper level air currents are going to determine how the air masses move. A front is a boundary between two different air masses. Now, on your reference table, page 13, you actually have symbols of the fronts, but I've actually drawn them in for you. Key thing to remember is the front marks the beginning of that air mass. So the air behind it is going to match that front. So if I look at a cold front, you'll see if you're looking at a weather map, it's blue triangles. The point of the triangle points the direction that the front is moving or going towards. All right, with that one, the air behind the front is going to be cooler than the air in front of the front. Doesn't mean it has to be drastically different. It just means it has to be cooler behind the front than it was in front of the front. So key is, as I said before, warm air can hold more water vapor than cold air. Keep that in mind for later. Here's our cold front. Now, cold air moves faster than warm air, so you have that curvature. So for us, our cold air, usually our air mass is continental polar. Like I said, it's dropping from Canada. So I have this continental polar air mass coming in. Air ahead of it is going to be warmer. So for us, normally, maritime tropical forming over the Gulf of Mexico area. So cold air can't hold the moisture. It comes in, it moves faster than the maritime tropical air. So what's happening is it's forcing that warmer, less dense air up and over its front. All right? As it pushes it up and over the front, as it gets pushed upwards, the pressure decreases. So this way the air parcel was able to expand. With less pressure, with the expansion, you don't have as much friction. Without that as much friction, your temperature is going to drop. So my temperature is going to drop, all right, as my parcel of air is expanded. With that one, I'm eventually going to hit my dew point. Dew point is temperature at which water condenses. With that one, once I can condense, I'm starting to build my clouds. So if along my cold front, I am going to be building clouds along the front. If I am going to have precipitation, it's going to happen along the front. All right, so we kind of went over how the clouds are being built. I got to evaporate water. I got water vapor in the air. All right, as it gets pushed upwards, less pressure expands. It cools. Once it hits the dew point, it will condense. In order for condensation to occur, water vapor needs something to cling onto. Without a condensation nuclei, you will not get condensation. So for us, what it usually is some kind of pollutant in the air, be it pollen, dust, or any kind of pollutant coming out of like a factory, or your exhaust, or coming out of your house. So water vapor is going to condense onto that. So when it actually precipitates, it actually cleanses the air because it brings that pollutant down out of the air. During a cold front, cooler air, as I said before, rushes in. That warmer, less dense air is pushed upwards. All right, cools to its dew point and forms clouds. So if I'm looking before a cold front, the temperature is obviously warmer. We had talked with heat transfer as 8th grade review, that pressure and temperature are inversely related. They're opposite each other. So if my temperature is warmer, my pressure had to be lower. All right, lower pressure also allows more and more clouds to build. So my temperatures before the front are warmer, my pressure is lower. Warmer temperatures for us are coming out of the south or southwest, mostly out of the southwest because we're in the prevailing southwesterlies. As the front approaches, what happens to my pressure is going to drop. As it drops, it allows more clouds to build. If I'm having precipitation, if there's a drastic difference in temperature and humidity before the front and after front, precipitation usually occurs right along the front. Possibly that heavy downburst of rain, and then it clears up later. After the front, the cold front has gone through, the air behind it is cooler. All right, if the air is cooler, my pressure is going up. And my winds are coming from the north or northwest. Like I said, we're bringing cooler, drier air in from Canada. So that's my cold front. Warm front, my symbol is up there, it's the red, it looks like half circles. If you're looking on a weather map, that's what you'll see. For us, warm front air mass is usually a maritime tropical. So the warm air, it's warmer and more humid air usually behind the front than in front of the front. So we're going with continental polar in front of the front. Notice the shape is very different. That's because your warm air doesn't move as fast as your cool air. So with that one, my warm air, as it comes over the cooler, drier air, it's going to get forced up because remember, it's less dense. As it gets forced up, what you're doing is you're building clouds. You're building clouds on the front and in front of that warm front. So if I'm looking at it, I got more precipitation. This is the one that is at steady rainfall. If I'm looking before the front, my temperatures are cooler, my pressure is higher, my winds are from the north and northwest. Same thing as my front approaches, dropping my temperature, sometimes wind increases, I build my clouds vertically. As I said before, precipitation is in front of the front, and it's a steady precipitation. After it, remember, the air behind the front has got to be warmer than the air in front of it. So if my temperature is warmer, my pressure is dropping, and my winds are coming from the south or southwest. So we did cold front and warm front. Very different from each other. Next front, stationary front. Notice you have your cold front symbol on one side, warm front symbol on the other side. Stationary means it's not moving. It's staying there for an extended amount of time. Weather is going to be similar to that of a warm front, so precipitation. Your next front is an occluded front. All right, this one starts out as a stationary front. So I have my continental polar, my maritime tropical. Then what's going to happen is I have another cold air mass coming in. Remember, cold air is moving faster than warm air. So what's going to happen is that cold, that continental polar on the left-hand side is going to move faster and right through into that maritime tropical air mass. So with that one, remember, the maritime tropical air mass, that air is warmer and less dense. That's going to get forced up and over both of the cooler air masses. So with that one, my weather is going to be more similar to a cold front. All right, so we've done our fronts now. Next, pressure systems. We're going to start with a low pressure. This one, if you're looking on your weather map, I need you paying attention. Low pressure is marked with a capital L. The winds in the low pressure system here in the northern hemisphere move counterclockwise and in towards the low. Remember, we talked earlier, as 8th grade review, winds always blow from high pressure to low. So they're moving towards the center of the low, which is you got your lowest value of pressure. Low pressure, because I'm allowing air to get pushed upwards. All right, as it moves upwards, remember, it's cool, it's expanding, so it's cooling, and it's eventually going to hit its dew point. With that one, low pressure is usually associated with precipitation. High pressure, on the opposite, the winds are moving, for us, the winds are moving clockwise and outwards. Remember, moving from the highest out to something that's lower. High pressure, I'm forcing air down. Forcing air down, the air is warming up. I'm not going to hit my dew point, and since I'm not hitting my dew point, high pressure is associated with clear skies or fair weather. So what I did was I took a couple pictures of weather maps from today. So if I'm looking at it, do you see the L's? The red L's are your low pressure system. Notice you have more precipitation in that area. The high pressure, high and dry. Also underneath I have my temperatures. So if I'm looking at my temperatures, if I look at the northeast, notice my temperatures are warmer, especially in New York State. Because if I look here, we had a warm front before. So the air behind it is warmer. If I go back, we have a cold front coming in. If I look here, here's my cold front. All right, remember, cold air can't hold the moisture. If I look back where the cold air is, I have one also right here, is cold front here too. Air behind the front is cooler than the air in front of the front. Notice your fronts also extend out of your low pressure systems. They are not associated with your high pressure. They come out of the low pressure. And also I put up a dew point. The closer your dew point temperature is to your actual temperature, the more humid it is. Alright, the further away, the less humid it is, more comfortable it is. So on those really hot, steamy days, usually your dew point is very high. That means there's a lot of water vapor in the air. So when you're sweating, the more water vapor in the air, it's harder for your sweat or perspiration to actually get evaporated. That's what's actually cooling you down when the sweat evaporates. If you can't evaporate that, you feel hot. What instruments am I using for meteorology? First one, you guys have used the thermometer before. A thermometer is used to measure temperature. A windsock. You might have seen a windsock. University Hospital has a windsock. That's because they have that helipad. So the planes, the helicopters need to know how windy it is and what way the wind is coming from. So it has sections here. The windier it is, the more sections will extend straight out. It also is allowing us to see which way the wind is blowing. Another instrument used is a barometer. Barometer is going to measure air pressure. Two different units. One is in millibars and the other one's in inches of mercury. So with this one, as your pressure increases, you're less likely to have precipitation. If it decreases, you're more likely to have precipitation. And if the pressure stays the same, it's called steady on your barometer. A wind vane or a weather vane, it shows me a wind direction. This is one that sometimes people have on top of their roofs. Alright, the shark here is pointing the direction the wind is. Anemometer. So you have those cup-like objects, and what happens is wind hits the cup, the curve, it forces it to move. The faster it moves, the greater the wind speed. Okay, and the sixth one is my sling cyclometer. Sling cyclometer you're going to do for dew point or relative humidity. So if I'm looking at that one, you have what they call a wet bulb. It has what they call a sock on it. So the sock, you actually wet it with water. And then you have a dry bulb, which is a regular thermometer with nothing on it. So you'd wet the thermometer and you'd go and you actually go out and rotate it. And what you find out is the water from the cloth sock evaporates. And as it evaporates, it cools down. The more it evaporates, the cooler it makes the wet bulb. The higher the humidity, less is going to evaporate. So if you're at 100% humidity, where it's like raining, your wet bulb and your dry bulb are going to be the same because nothing's going to evaporate. All right, if there's a drastic difference between your wet bulb temperature and your dry bulb temperature, it tends to be very dry. Okay, for that one, we can use your reference table. Be looking for another video coming up to learn how to use the wet bulb and dry bulb to determine the dew point and relative humidity. So be looking in your stream for that.